This circuit can then be considered a series resonant circuit. Each time a quarter wavelength is added to the circuit, the condition changes. Thus, open and closed end lines can be used as parallel or series resonant circuits, according to the length of line used. Because of this facility, they are known as resonant lines or tuned lines. In this quarter wavelength of open transmission line, we have the requirements for a radio antenna. Let's take a quick look at the electric field here. Because the current flows in opposite directions in the two conductors, the directions of the magnetic fields are opposite, and any radiation is cancelled. How can we use this device as an antenna? Very simple. We spread the wires apart. Presto, a dipole antenna. Notice that the current flow is in the same direction in both conductors, or in other words, the same in both halves of the antenna. The direction of the magnetic fields is now the same, and instead of opposing each other, they strengthen each other. This is your basic antenna. It is called the half-wave dipole antenna. Our tabletop antenna system uses a half-wave antenna. Let's examine the kind of radio waves it sends out. The vertical rings represent the magnetic lines. The horizontal rings, the electrostatic lines. Let's say these lines form a single wave, and we'll stick with this wavefront as it is radiated into space. Upon leaving the antenna, the pattern enlarges. It stretches, yet the magnetic and voltage lines retain a fixed relation to each other and to the earth. For instance, stopping the wave, we see that the magnetic or H lines are still perpendicular to the voltage or E lines. Also, we see that the E lines in this wavefront remain horizontal or parallel to the Earth's surface. Because of the direction of the E lines,